Now, two smooth spheres. Right. Two smooth spheres P and Q have equal radiuses and are mass m and 2m respectively. They collide obliquely, alright? So what got most people in this was the 4. You didn't break it up into its components. So the 4 is going up in this direction here. But you're told about the angle, aren't you? You're told that it's angle A of 2 over 4 over 5. Okay? So this is 4 cos A, and this is 4 sine A. And if sine A is 4 over 5, this would mean that cos A is 3 over 5, using a standard 5 for 3 right angle triangle, yeah? So it's going to be 4 times 3 over 5. So what's 4 times 3 over 5? Anybody 4 times 3 over 5? 2.4? Or 2.4, yeah. Right. And then the other one, 3.6, is it? 3.2, sorry. So now, happy enough with that? Now, when you're talking about the collision, you're talking about two circles coming together, or two spheres, and what's happened is they're both colliding, and one of them has no speed in this direction. Do you get what I'm saying? This one has no speed in this direction. It's a 0 speed. It's not moving left or right in this direction, but it is going up at 3.2. What about the second one? It's coming across at 2.4 and it's rising up at 3.2. So they're actually matching each other's speed, all right? But then what happens is, after the collision, what are we suspecting happens? That the 3.2s are maintained, aren't they? Because they're perpendicular to the axis of the crash. The axis of the crash attaches the two centers of the spheres to each other. So the 3.2s are perpendicular to that. So the only thing that's getting affected is the 0 and the 2.4. So therefore, what we think of, you can use letters if you want. I'll call that P, and this one Q. I have them both moving to the right. If they're moving to the left, I'll get a negative answer, won't I? So let's do principle of conservation of momentum. What do we think? M1, which is it just M? M times 2.4 plus what's this one? The weight of this one is 2M and M, yeah? So it's going to be 2M times 0. And what else after that then? What about after? M times P, and the other one? 2M times Q. What do we get then, guys? Take all the M's out and you get P plus 2Q equals 2.4, yeah? Next we're going to do is NEL, Newton's experimental law, where V1 take V2 equals minus E into U1 minus U2. So P minus Q is in fact the same thing as what? Do we have an E value? We do not have an E value. And what's U1 take U2? What is it? Yeah, 2.4 take away 0, is it? Give me a sec. Is this before the rebound question? Or after? Oh, there it is. Got it. All right. So what do we got here, guys? 2.4, yeah? NEL. So P minus Q is minus 2.4 E. Now this hurt a little bit, alright? So what we're going to do is we're going to do minus 2.4 P, sorry, multiply by 2, will we? Yeah, we'll multiply by 2. And we'll get minus 4.8 E equals 2P minus 2Q. 3P is 2.4 minus 4.8 E. Once we divide that by 3, 0.8 minus 1.6 E. Now you're not wrong with that, but the way they took out the 0.8 and they left that as 1 minus 2 E. You don't have to do that, but is that right? And similarly, Q came out to be 0.8 plus 0.8 E, and then Q turned out to be 0.8 into 1 plus E, using the same sort of math. Now, key word in this question, it wants the velocities, okay? And also if you've only given this direction. You've only given the velocity in the x direction, and you've neglected the velocity in the y direction. So with both of these questions, what you have to write down was the following. You have to write down the velocity of P was 0.8 into 1 minus 2E. That's in the I direction. And the 3.2J in the other direction. And that's where a lot of people lost a couple of marks. So that's why a few people got done there. And many people fell into that pitfall trap there. And you had everything else right though, did you? Yeah, it's annoying.